In today's video, we will be talking about power once again. After watching this video, you should be able to have some new equations that express power in terms of current, electric potential difference, and resistance. So really what we're going to start to do is we're going to start to tie Ohm's law into some new power equations, which will be quite useful for solving some problems that we'll be running into. So let's get right to it. Just again, a reminder of what power actually is. Electrical power is defined at the rate at which electrical energy is supplied to a circuit or consumed by a load. Okay, so we had talked about, I believe, a few lessons back about that on a light bulb if it says 60 watts on it. The watt is the unit of power, and basically one watt equals 1 joule per second. Okay, or per 1 second. And so if you have a 60 watt bulb, basically that bulb every second is using 60 joules of energy. All right. Well, in the previous lesson, we talked about Ohm's law, and what we've done basically is we've used Ohm's law and we've inserted it into a couple different power equations that will be quite handy. So I highly recommend having these in a useful location for the next couple lessons, because these equations will be useful. So the first one is power equals the voltage times current. Okay, power equals the voltage times the current. So then using Ohm's law, we can basically derive two new power equations, which are below. Power equals the current squared times the resistance. And then another one we can have is power equals the voltage squared divided by resistance. Okay, so these three equations are now fair game for power equations that we can use. And basically, this whole lesson, I'm just going to be doing a few example problems dealing with these new power equations. Okay, so let's get right to that. Let me just change pen colors here so it's something a little more friendly than red. Red seems angry to me. So the problem is calculate the resistance and the current of a 7.5 watt night light bulb plugged into a U.S. household outlet. And most U.S. households use 120 volts. Okay, so let's write down what we know first. I highly recommend getting into the habit of doing exactly that. So we know that the power of this night light is 7.5 watts. We also know that the voltage is 120 volts. Okay. I want to know the current, and I would like to know the resistance that's basically happening here in this circuit. Right. So the first power formula I'm probably going to use is, and there's a couple ways you can go about doing this, but I'm going to use the first one where P equals I times V. Okay, because I know power and I know voltage, and then I can find out my current. Okay, so I'm just going to plug some numbers in here. 7.5 watts is equal to I, which I don't know, times the voltage, which is 120 volts. Right, and basically, if you do the algebra on that bad boy, you should get a really small current of 0.0625 amps. Okay, so now I know the current. Awesome. All right. Now I'd like to figure out what is the resistance here. All right, and we can use a couple equations, but the one that I'm thinking I might use is this one, where we have power equals voltage squared over resistance. Okay, and I already know the voltage, I know the power, and then I can find out my resistance. All right, so basically, what this would look like will be basically P is 7.5 watts is equal to 120 volts, and that's squared, over R. Okay, and if you get R by itself, you would get a resistance of 1,920 ohms. Okay, and that would be the answer to that problem. Okay. Do not forget to square things. That's where students will sometimes make mistakes, is that they forget to square stuff. Let's take a look at another problem. Calculate the resistance and the current of a 1500 watt electric hair dryer plugged into a US household outlet of 120 volts. Okay, let me just grab a different pen color just to make things interesting. Let's go with magenta. All right, so again, what do I know? Well, I know the power of this guy is 1500 watts. And I know the voltage is 120 volts, and I'm wondering what the current is and what the resistance is. Okay, so let's start off with let's find the resistance first, just to switch things up from the previous slide. So to find the resistance, I'm going to be using the equation P equals V squared over R. Okay, so my power is 1500 watts, and I'm just going to plug numbers in, equals V squared, which is 120 volts squared, over resistance, right? And basically, if you do that algebra, you should get a resistance of 9.6 ohms. Okay, and again, I'm doing this kind of fast, but hopefully you can get R by itself after you've done the algebra, and then if you do the math, you would get 9.6 ohms as your resistance. Okay, well let's now find out the current. So I'm not interested in the current. I'm going to use the one other equation that I haven't used so far. P equals I squared times R. Okay, so we just found R, so I'm going to be using this newfound answer in this equation. So the power is 1500 watts, and I squared, I don't know, times R, which is 9.6 ohms. Okay, so what I'm going to do is basically do this algebra here, which again, this one might not have been the best one to use, because anytime you can avoid, I think, square roots and all that stuff, I don't think it's a bad idea to do, just because it makes the math more challenging. Why make that more hard? Why make it harder than it needs to be, is what I always say. But if you get I by itself, basically, you should find out that the current is 12.5 amps. Okay? And so that would be my answer. Okay, and so these are just, again, just showing you how you can use these different formulas in different ways to basically find out stuff about circuits. Okay, whether you need to find out power, whether you need to find out voltage, current, or resistance, you really can do it now, because between Ohm's law and then these new equations that from the power formulas, you can find out a lot of information from these circuits. That takes care of today's video. I will see you guys next time.